At 6:32 in the morning on April 21st, 1944, Staff Sergeant Robert Mitchell stood beside a P-51 Mustang at Debden Airfield in England, watching his pilot walk toward an aircraft that had a single point of failure he could not fix. The pilot was Lieutenant James Parker, 22 years old, 14 combat missions, 3 confirmed kills. The German defences had just moved 9,488 flak batteries around Berlin. Parker would be flying straight into them on a bomber escort mission to Parkheim. Mitchell had been maintaining P-51 Mustangs for 7 months. He knew the aircraft inside and out. Single-engine fighter, laminar flow wing, fast at all altitudes, range of over 1,600 m with drop tanks. The Mustang was the best escort fighter in the world. But the P-51 had one fatal vulnerability that was killing American pilots every single week. The Rolls-Royce Merlin engine ran on a coolant system filled with ethylene glycol, a mixture that circulated through the engine block, through brass tubes in the cylinder heads, into a header tank behind the propeller, then down through exposed lines to a radiator mounted in the belly of the aircraft. The entire system held approximately 17 gall of coolant. One bullet anywhere in that system meant the engine would overheat within 3 to 7 minutes. 3 to 7 minutes before the engine seized. 3 to 7 minutes before the pilot had to find somewhere to land or bail out over enemy territory. American doctrine said P-51 pilots should stay at altitude, avoid ground fire, focus on fighter escort duty, use speed, use altitude, never go low where small arms could reach you. Parker had tried that doctrine 13 times. It had not stopped him from getting hit. The 8th Air Force had lost over 500 P-51s in the past 6 months. Most were not shot down by German fighters. Most were brought down by ground fire, by flak fragments, by rifle rounds that punched through aluminum skin and severed a coolant line. Mitchell had watched too many pilots limp back to base with white glycol vapor streaming from their aircraft. Engines running hotter and hotter, temperatures climbing past 100 degrees C toward the maximum of 110. Some made it back, most did not. The training manual said the problem was tactical error. The instructors said these pilots were not following doctrine, but Mitchell knew better. The problem was not the pilots, it was the cooling system. The P-51 Mustang cooling system was elegant, was efficient. It used the Meredith effect to recover some of the drag penalty from the radiator, but it was vulnerable. Every coolant line ran exposed through the aircraft structure. The header tank sat directly behind the propeller with thin aluminum walls. The radiator hung in the belly intake where it was exposed to anything coming from below. A single .30 caliber bullet could puncture any of these components. A single piece of shrapnel from an 88 mm shell could tear through a coolant line. Once the system started leaking, there was no backup, no reserve tank, no way to seal the leak in flight. The coolant would stream out through the hole, the temperature would climb, and the pilot would have minutes to decide whether to try reaching friendly territory or to bail out where he was. Mitchell had mentioned this to the engineering officer 4 months ago. The officer said the cooling system met all specifications. North American Aviation had designed it. Packard had built the Merlin engines. Everything was within tolerances. Everything was within tolerances. Changing the design would require re-engineering the entire aircraft. That required approval from Wright Field in Ohio, and Wright Field was 4,000 miles away. Modifications would take months, maybe years. The pilots did not have months, so Mitchell did what he could. He checked every coolant connection before every flight. He telecked every hose clamped to specification. He pressure tested the header tank. He looked for cracks, for corrosion, for any sign of weakness in the system. But he could not armor the lines. He could not add redundancy. He could not fix the fundamental vulnerability that every P-51 carried into combat. The first pilot Mitchell lost to cooling system failure was 2nd Lieutenant David Chen on March 19, 1944. Chen had been in theatre for 4 weeks. Mitchell had worked on his aircraft every morning. They talked about California. Chen was from San Francisco. Mitchell was from Los Angeles. They had both worked on cars before the war. Chen took off at 6:45 on a fighter sweep over France. He came back 3 hours later with his engine temperature gauge showing 108 degrees C and a trail of white vapor behind his aircraft. Chen said he had been hit by ground fire during a strafing pass on a German airfield near Bove. Single-round small caliber punched through the belly skin and clipped a coolant line to the radiator. Chen felt the engine temperature start climbing immediately. He broke off the attack, started climbing, pointed the nose toward England. The engine held together for 18 minutes. 18 minutes of watching the temperature gauge climb, watching the vapor trail grow thicker, knowing the engine was dying. Chen made it across the channel. He made it to the English coast. He made it within sight of Devon. The engine ceased 4 miles from the runway. Chen tried to glide in. He almost made it. The Mustang came down in a field 3 miles short, flipped on its back, broke apart. Chen died in the crash. The official report said pilot error. Should have bailed out over the channel when the engine was hit. Should not have tried to bring the aircraft back. Mitchell read the report and knew it was wrong. Chen had done exactly what any pilot would do. He had tried to save his aircraft and get home. The cooling system had killed him anyway. The second pilot was First Lieutenant William Morrison. Morrison was a flight leader, experienced with 9 kills and 28 missions. He knew the P-51 inside and out. He knew its strengths and its vulnerabilities. He flew smart. On April 7th, 1944, Morrison's flight was providing close escort to B-17s over Brunswick. They encountered heavy flak at 22,000 FT. Morrison's aircraft took a hit from an 88 mm shell. The shell did not penetrate the cockpit. It did not hit the fuel tanks. It burst 22 to the left of Morrison's aircraft and sent shrapnel through the left side of the fuselage. One piece, maybe 3 in long, cut through the aluminum skin and severed the coolant line running from the header tank to the radiator. Morrison called it out on the radio immediately. Coolant leak, temperature climbing. He stayed with the bombers for another 6 minutes while they completed their bombing run, keeping the German fighters off them, even as his engine temperature passed 100 degrees. Then he broke off, dropped out of formation, headed west. Morrison's wingmen stayed with him. WWII with him. They crossed into friendly airspace over Holland. Morrison's engine was running at 112 degrees, past maximum permissible temperature. The cylinder heads were starting to warp. Morrison tried to nurse it, reduced power to minimum, kept the nose down to maximize airspeed and cooling airflow. The engine seized over the Zoid at 8,000 foot. Morrison tried to restart. It would not turn over. He set up for a forced landing on a beach on the Dutch coast. He almost made it. The Mustang hit hard. The landing gear collapsed and the aircraft cart were wheeled. Morrison died on impact. Morrison's crew chief was a friend of Mitchell's, a guy named Rodriguez from Texas. Rodriguez was convinced the cooling system was the weak point. He pulled the maintenance records for every P-51 lost in the previous 3 months. 42 aircraft, 27 had been lost to cooling system failures after battle damage. 27 pilots killed because a single hit had knocked out the entire cooling system. The official reports blamed tactics, said the pilot should have stayed higher, avoided ground fire, followed doctrine. But Rodriguez showed Mitchell the combat reports. Most of these pilots had been following doctrine. A sharp bang under his left foot, like someone had kicked the floor of the cockpit. The engine temperature gauge jumped 5 degrees immediately, then 10, then 15. Hayes keyed his radio, took a hit. Coolant system, temperature climbing. He levelled off at 4,000 FT and pointed the nose west toward England. The vapor trail started 30 seconds later. White glycol mist streaming from under the cowling, visible to everyone in the formation. Hayes watched the temperature gauge. 100 degrees, 102, 104. He reduced power to minimum cruise. The temperature stopped climbing at 106 degrees. Hayes did the math in his head. He was 180 miles from Devon. At minimum cruise speed, that was 40 minutes of flying. The engine manual said maximum continuous temperature